All right, so now I'd like to talk about some different types of statistical studies that we can conduct. So remember that the subjects of our study are going to be the people, animals, living things, objects, cars. That's going to be our subjects. If we are studying people, you might want to call them participants, right? They volunteered to participate. They said that it was okay. So just as a clarification for the difference between subjects and participants. So for our study, we first need to identify some variables. So a variable is any item or quantity that can vary or take on different values. So for example, things like height, weight, hair color, income level, okay? Those are variables. We as people have so many variables we could study. It's insane. Variables of interest are the items or quantities that a study seeks to measure. So if I'm studying your IQ, I probably don't care about your weight. I probably don't care about your height, right? I doubt those have any effect on your IQ. An explanatory variable is a variable that may explain or cause the effect. And a response variable is a variable that that responds to change in the explanatory variable. So if I eat more ice cream, my weight will probably go up. So that would be our explanatory variable and our response variable. So let's look at some variables of interest for this study. A poll in which college students are asked about their study habits. Okay? What would we want to study? If we want to know about student study habits, let's brainstorm some ideas. I'm going to write a few down, but you might think of others. So you might want to know how often they study. You might want to know their GPA. You might want to know their major, right? You might want to know, do they study alone or in groups? These would be really good questions to have answered by this study. So there are two basic types of statistical studies. One's observational. So this is where researchers observe or measure characteristics of the subjects but don't attempt to influence or modify these characters in any way. An example of that would be like a survey. The other type of study we can conduct is an experiment, okay? So this is what's typically done in the medical field. This is when researchers apply some treatment and observe the effects on its subjects of the experiment. Keep in mind, a treatment doesn't have to be a medicine or a drug. My treatment could be, hey, I want you to go for a half-hour walk every day, or hey, I want you to listen to this motivational podcast, or go to yoga. Like, treatment doesn't have to be medical or a medicine. There are two different types of observational studies. One is retrospective, right? This uses data from the past. And the other is prospective, okay? This is set up to collect data in the future from groups that share common factors. So let's say you want to know whether teens who try marijuana are more or less likely to abuse hard drugs as an adult. What type of observational study you should do? First off, we do not want to do an experimental study. We are not giving these people marijuana. But what type of observational study should we do? Well, if we did a prospective, we're just waiting to see if these teens grow up into adults who abuse hard drugs. So the type of study we should probably do would be a retrospective study. Experimental studies have a couple of things different from observational studies. So one is that there's going to be a couple different groups. There's going to be a treatment group, so that's those who receive the treatment, and there's going to be a control group. That's those who do not receive the treatment, right? We need a control to see if our treatment has any real effect. So let's say a study divided college students into two groups. One group listened to classical music before being given a specific task, and the other group were given the task without listening to classical music. Researchers found that those who listened to classical music performed slightly better if they did the task within a few minutes of listening to music. The two groups performed equally on tasks completed later. So what are the treatment and the control groups? And what was the treatment? So the treatment in this case was listening to classical music. The control group was those who did not listen to music before completing the task, and the treatment group was those who did listen to music before completing the task. A study can suffer from confounding if the effects of different variables are mixed, so we cannot determine the specific effect of variables of interest. Okay? These are variables that lead to confusion are called confounding variables. A placebo is a treatment that lacks the active ingredient. This is primarily used for medical studies, right? So the participants cannot distinguish whether they're receiving the placebo or real treatment. One thing, though, is this can lead to the placebo effect. This refers to the situation in which patients think they're getting a treatment, so they start to feel better just because they believe they're getting treated. One type of confounding that can happen in experimental studies is experimenter effect. Okay? This is when the experimenter knows which participants are in each group. They know who's getting the treatment and they know who's not. Okay? The only way really to avoid experimenter effect is to make sure that the experimenters don't know what subjects are in each group. Okay? We can do this by blinding in experiments. Okay? So in a single blind experiment is when the participants don't know whether they're in the treatment or control group. This is always the case. But to make sure we don't have the confounding variable of experimenter effect, we need to have double blind. That means neither the participants or the experimenters know who is in the treatment or the control group. So for each of these below, identify any problems and explain how the problems could have been avoided. So let's say a new drug for ADHD is supposed to make affected children more polite. Randomly selected children suffering from ADHD are divided into two groups, and this experiment is single blind. So the experimenters know who's in the control group and who's in the treatment group. And the experimenters evaluate how polite the children are during one-on-one interviews. What's the problem here? So the experimenters know who's getting a treatment and know who's isn't. We know this drug is supposed to make these children more polite. So a problem is that the experimenter, when interviewing someone in the treatment group, could be more kind or tread more softly in their conversation in order to get the results they desire. That would be experimenter effect. What if a chiropractor performed adjustments on 25 patients in back pain, and afterwards 18 of the patients said they feel better? He concludes that the adjustments are an effective treatment. What's wrong with this? So first off, they could just be saying, oh yeah, I feel better to make him feel better, right? But there's no control. Who's to say these people just wouldn't have felt better as the day goes on? All right, so let's bring things all together. So what are our basic steps in a statistical study? Oops. What did I do here? Okay, basic steps in a statistical study. So the first thing I want to do, we want to state the goal of our study, right? We need to know what our population is going to be, and we need to know exactly what we want to learn about it. Like, you can't just say, I want to study students. You can't just say, I want to study people or cars. You need to narrow that down and be more specific. Next, you need to choose a representative sample from your population, right? Do that using the sampling methods we discussed in a previous section. And then you're going to collect raw data from the sample. You're going to collect this data and you're going to summarize it by finding sample statistics of interest. That's what we're going to talk about in Chapter 2. We're going to talk about descriptive statistics and inferential statistics. And then we use these statistics to make an inference about our population. And then we can draw conclusions. We need to determine what we learned and whether or not we achieved our goal. Even if you didn't achieve your goal, let's say you didn't, you weren't able to survey enough people, or your treatment didn't work, that's okay, right? That still informs the literature. And what that means is now we know what not to do, right? So it's still a successful study, even if you don't get the results you desired. So let's talk about the different types of data we could collect when we develop a survey. So first off, data is the information collected, and those are the values of our variables. And a datum is a silly word, but it just means a single variable. So types of data we can collect, I'd said this before, when it comes to people, we could talk about age, race, height, weight. We could even study students' GPA or favorite subjects. There's lots and lots of information we can collect. Now, once I've collected all this data, we can calculate a statistic. So this is a number which would represent a property of our sample. So for example, we could calculate the average height, average age, mean height. We could figure out what the most popular subject of students is, what their average GPA is. And these statistics from our sample, we can use these as long as we had a representative sample to see what our population parameter is. So when we study a sample, we're really examining their variables. They're typically labeled with a capital X or Y, right? And again, some of the variables we could study about college students are age, eye color, class standing, major, possibilities are endless. So data are the values of, that's an O, values of a variable. And data comes from a population or a sample. Again, represent the variable with a capital X, and then the data is represented with lowercase letters, corresponding lowercase letters. So there's two main types of data. There are numerical or categorical. Numerical takes on a number. Look at the word, break it down. Numerical means it takes on a number. So like age, height, weight, year, things like that. A categorical value goes into a category. So like eye color, class standing, gender, things like that. So we have two different data types, numerical and categorical, okay? And those are also called qualitative and quantitative data. So qualitative data looks at the qualities, okay, of a variable, right? So it consists of values that are placed into categories, okay? Examples, hair color, blood type, ethnic group, okay? The data in the values are words or letters. Quantitative data consists of values representing counts or measurements, so like heart rate, number of people in a city, weight, and anything we can assign a number to. There are two types of qualitative data. There's discrete data and continuous data, okay? So let's figure out which of the following is qualitative or quantitative. So brand names of shoes in a consumer survey. What are some brand names of shoes? Nike, Adidas, okay? Those are going to be qualitative data. Scores on a multiple choice exam. You could get 5 out of 10, you could get 7 out of 10. That's numerical, so that's going to be quantitative. So quantitative data can take on, can either be discrete or continuous. So discrete data can only take on particular values and no other values in between. Okay? Most of them are going to have counting values, like 0, 1, 2, 3. That's how we count. Those are the counting numbers. So an example of that would be the number of phone calls you get a day. I get between 3 and 4. My shoe size, 8.5. But remember, shoe size can only take on like half values. It's like size like 5, 5.5, 6. So this would be an example of discrete data. Continuous data can take on any length in a given interval. Typically, these are things you measure, right? You can measure someone's height. You can measure someone's weight. You can measure the length of phone calls you get in a day. So let's go ahead and determine which are discrete and which are continuous or qualitative. So the number of shoes you own, can that take on partial values? Can you own 7.3 shoes? No. So this is going to be discrete. What about the type of car you drive? Well, that can't be measured, right? That's going to be qualitative. How about the distance from your home to school? That's going to be continuous. What about the number of courses you take in a semester? Well, the number of courses you take in a semester, that's something you count. That's going to be discrete. What about the weight of an orange? That's continuous. That's something you measure. How about IQ scores? Right? Remember, these are measured, right? You have to measure it with a test. But this is actually going to be discrete because it can only take on specific values and it can't take on half values.